We've run through our popsicle method where we had to then rinse it out with acetone, and we've had this MI basically spinning on a spinner, and we replace the water above it every day. And the water is supposed to absorb the acetone. If we've done enough of that, we should have got our MI density back. So in this procedure, we're basically going to be taking the MI, make sure it's at the right density, and then filter it so it's ready for heavy liquid separation. You'll see I'm wearing these special gloves that are acetone and MI resistant. These always stay in the hood. And so when I come into the hood, I put these on. When I leave the hood, these come off. So in the hood, out of the hood. I'm going to show you that one more time so it really takes it home. So gloves in the hood, gloves off out of the hood. And besides my safety gloves, I'm also wearing a mask or a shield. This shield is extremely important because the MI is extremely of a low viscosity. So if you do make a mistake, it splatters and sends a spray. You want to make sure you protect your face at all times. You'll also notice I wear a pair of gloves underneath my protective gloves. Just one more step in protection. The reason why I'm wearing all this safety gear is because MI is suspected of being carcinogenic and mutagenic. So it's nothing that you want to mess around with. It has the vapor pressure of alcohol, close, plus or minus. So it will evaporate. You might think, oh, it's gone, just like alcohol. But the problem is the worst part of the MI are the salts that are left after it evaporates. So everything you see here does not leave this hood until it's been completely rinsed with acetone, and then I take it straight over to the sink and soap everything down. And then, only then, is it safe enough that you can consider it clean. And I have my whole station here laid out. And that's pretty much just a bowl that sits in its tri-corner beaker. So that's my stand. The beaker's nice because when the bowl gets MI into it, you want to keep it in a safe place from rolling around. Next thing we have is a funnel with a filter paper that will make sure you don't let anything through that filter. So it has to have an extremely tiny mesh. And then an empty MI bottle ready to receive everything we're recycling. And then we had this giant pipette made in the chemistry department. And we had it made kind of special so that the opening is extremely small. That opening is about a 32nd. And you'll find that it fills slowly with the MI, which is kind of a pain. But the beautiful part is it doesn't run out easily either. So it allows you to very precisely move MI around without sloshing it, dropping it, or making a mess. So if you want to do something like this, all you have to do is heat the tip up with either like an oxyacetylene torch, and it will naturally constrict. So if you don't have one of these or a chemistry department with a glass maker, go ahead and heat up your own. Next we have a hydrometer here, and this hydrometer is special for MI. So it measures density from 2.9 up to 4.0. So we have that. Then for that hydrometer we have a non-graduated cylinder. And we had this one specially made so it has a bit fatter of a base and much taller, because sometimes if you can't buy the short stubbier hydrometer, you need a lot more MI for this thing to float in. And then finally, we have our flask full of MI that needs to be recycled. We've poured off all the water on top as much as we can before we started pouring out MI. The most crucial part of this whole process is your bulb handling skills. And I say that only 10% facetiously. So the way it works is the bulb's threaded on this hole into the pipette. Now it's crucial that every time you're going into the flask, you're blowing air out of the tip to prevent any water from getting in there until you're at the bottom of the MI. Then you're going to let it suck the MI up into the bulb. Now the hardest part is getting the bulb with MI out of the flask without anything splurting out of the top, and then getting it either into the graduated cylinder or into the filter paper without it sloshing down and squirting out. The first thing, as you're putting the pipette through the water into the MI, you want to be squeezing the bulb. And that makes sure you're blowing water out of the tip, keeping water out of the pipette until you puncture through that and you get into the MI. Once you're in the MI, you can release the bulb and take MI into the pipette. The hardest part comes next. And that's because as you're pulling it back out of the water layer, you want to squeeze so you're blowing MI out of the tip. And then as soon as you're above the water, you want to release the bulb so you're taking air into the pipette as you tip the whole thing out. Once it's out, you want to then squeeze it so you have some space in your bulb to maneuver. And then as you want to tip that into the cylinder or your filter paper, you then release the bulb so you're once again sucking air into the tip, preventing MI from coming out. It's always that balance. A good thing to do also is make sure that wherever you're going to transfer the MI, the next place is really close. So right now I have this cylinder as close as I can get it to the flask, because we first have to measure the density. Then I'm going to push the flask so it's super close with our funnel, because the longer you have to travel, more stuff you have to do. So squeezing air out as we go down, then we release to pull the MI in. And I have a technique where you don't have a third hand, so one hand has to tip, while the other hand has to squeeze the bulb, and then I lay the pipette right between my thumb and forefinger so that it keeps it from falling off as I do the tip. Here we go. So you're going to grab the rim, get ready to catch that. So squeeze MI out above the water. Then we're going to get ready to tilt by sucking air in. Do our tilt as you tip it up. And then we're going to squeeze it out into the cylinder. Next, we're going to slowly install our hydrometer. You do not want to drop this. So you want to make sure that your MI is 3.3 grams per cubic centimeter, or you got to basically go back and rinse it with more water. This one's right at 3.3, so we're going to go ahead and take everything we can and apply it into our filter and back into our jar. Next thing to do is take the hydrometer out, and you can set it in that funnel where we're going to rinse everything. So MI is weird stuff. It's really low viscosity, so you got to make sure everything's off of it before you transfer it so you don't get a drip. Whoop. And there we go. You just take your cylinder and you pour it in. At this point of the process, it's just pulling it out of here, putting it into there. Here we go. So you're going to grab the rim, get ready to catch that. So squeeze MI out above the water, tilt, suck air in on the tilt, and squeeze some air out, then suck air in on the transfer. We have now transferred as much as we possibly can out of the rinsing flask. It's been placed into the filter paper. It's gone through the filter paper. The last thing to do is pretty much just wash up. So what I do is I make sure the pipette is totally drained out. Then I transfer the funnel that's in the MI over to the old rinse flask. So the quicker you can do this, the fewer drops you get. And here we go. Bing, bada bing. Then we cap our container of MI. The end of this pipette sticks up higher in the bulb, so you're going to get a little bit of MI that comes out of that, so I like to go slow and make sure all the MI can trickle out before I pull the bulb off. There we go. And now we're going to rinse it with acetone. and I've learned the hard way, if you're short, you do not want things running down your glove. So you have to make sure your glove is either kicked over or higher than whatever you're rinsing. So I'm going to bend my glove, and I'm going to rinse, making sure I'm getting acetone inside the pipette, coating all surfaces. So there's the pipette. Next, our hydrometer. You got to realize this thing is like as thin as a light bulb with a huge plug of lead at the bottom, so it's extremely fragile. Give it a nice 3 solid rinses. Making sure that you get all the drips off of it, and then you can set that aside. Our cylinder. So first make sure you get all the inside. There's 1, 2, 3, and then the outside. So that's 3 on the top. And then 3 on the bottom. Next is the bulb. So you remember we got MI into the bulb, so you have to do your darndest to get all the MI out with acetone. So put some acetone in, slosh it around, and then squeeze it out. But realize with the bulb you're not going to get it all clean. So what we do is we rinse it as good as we can, but then we actually have its own little tri-corner beaker here that we set completely aside. We set it out of the way that nobody else can mess with it. Now that everything's been rinsed, we're going to collect our filter paper. This is going to get disposed of specially through our waste management. So we set these aside. They'll be labeled and bagged again. Then we're going to rinse our funnels. And now we can take everything to the sink. It's going to get soaped, sponged. We're going to use a pipe cleaner for that. And for the pipette, we're pretty much just going to be able to get soapy water in there, slosh it around, and then sponge the outside. Once everything has been completely rinsed in soapy water, let it dry, put everything back where it goes. Last thing is going to be rinse these gloves with acetone, and then take them over to the sink and rinse them with soap. And so that's pretty much the whole process. If you have any questions, feel free to throw a comment down below.